Bismillahirrahmanirrahim. Assalamu alaikum, dear students. This is our next video. In this video, dear students, we are going to solve four problems. Okay. First two problems are from a set of four problems from problem number 31 to 34 of the book Calculus Early Transcendentals by James Stewart, Slim Watson and Daniel Clegg. And remaining two problems are problem number 35 and 36 from the same book Calculus Early Transcendentals by James Stewart, Daniel Clegg, Slim Watson. Okay, dear students, in first two problems we are going to find first and second derivative. Okay, while with respect to x, while function is of x with respect to x. Okay, similarly in second two problems we have to find actually function is of t and x, and we have to find dy by dx as well as dy by dt. Okay, so actually 35 and 36 problem are four problems in place of two. Okay, similarly problem number 31 and 32 are also four problems, because we are going to find f dash x as well as f double dash x. Okay, so these four problems are basically 8 problems. Okay, anyhow, before starting our solution in a formal manner, we first visit relevant snapshots. Okay, first snapshot is about product rule. Okay, we have discussed it in detail in our previous videos, so we do not go in detail of this definition. Okay, next is table of differentiation formulas. Okay, we have also dealt with this table in previous videos. However, problems in this video will also definitely depend on these formulas. Okay, because our topic is differentiation. Now, dear students, problem number 31. Okay, fx is equal to x squared into e raised to power x, exponential function. Okay, dear students, fx is given and we have to find f dash x as well as f double dash x. That is first derivative with respect to x and second derivative with respect to x. Okay, so when fx is equal to this, then f dash x will be equal to d over dx into the same function as provided in the statement. Okay, yes students, here product rule is going to be applied. Okay, because x square is a separate function and e exponential function e raised to the power x is a separate function. So so here product rule is going to be applied. In product rule, we know that one time we differentiate one of these two functions and keep other function as a constant, and second time we treat them alternatively. Okay, so d over dx x square e raised to power x will become equal to, first we keep x square as constant and differentiate e raised to power x with respect to x, and second time we keep e raised to power x as constant and differentiate x square with respect to dx. Dear students, we know that derivative of any exponential function is always at first stage is whole of the exponential function itself, and then in the second step substituted form of x, that is to say power of e other than simple x is then to be differentiated with respect to x. But here, because e raised to power x is purely in its original form, okay, as provided in the formula for exponential function, okay, so here we will not have to make any second step, okay. So x square is being multiplied because first time we have taken x square as a constant and we are going to differentiate e raised to power x with respect to x, which will give us the same answer as question itself, okay. Plus we have kept e raised to power x as constant and we are going to differentiate x square with respect to x. We know that the derivative of x square with respect to x is 2x according to power rule. So f dash x has become equal to x square e raised to power x plus 2x e raised to power x, okay. Now this implies that when f dash x is equal to this, then this implies that f dash x will be equal to d over dx into f dash x, and f dash x is equal to x square e raised to power x plus 2x e raised to power x, okay. Here, dear students, d over dx will distribute over these two adding terms, okay. After this distribution, two separate problems have come into existence, okay. d over dx x square e raised to power x and d over dx 2x e raised to power x, okay. Yes students, both these are a product formula, okay. In order to differentiate both these parts, we will have to apply product rule. And we know that in product rule, one time we keep one function as constant and differentiate other function, and second time we differentiate other function and keep second function as constant, okay. So we have gotten f double dash equal to d over dx x square ex plus d over dx 2x e raised to the power x, okay. Dear students, now if we see carefully, we come to conclude that d over dx x square e raised to power x is exactly original statement of fx at the beginning of this problem, okay. And we know that we have already calculated its first derivative, which is x square e raised to power x plus 2x into e raised to power x. So in place of d over dx x square e raised to power x, we will substitute its derivative, which we have already calculated in our previous part of this problem, okay. So half of the problem has almost been solved due to this facility, okay. Now we come towards the second part, which is d over dx 2x e raised to the power x. Here 2 is a constant, so it will not affect, it will just remain as it is as a multiplying factor. But x into e raised to power x are both being multiplied and both are separate functions. So in order to differentiate this part, we will have to apply product rule. And again, we know that in differentiating by using product rule, we one time differentiate one of these two functions and keep other constant, and second time we deal with these two functions in an alternative manner, okay. So in place of d over dx x square e raised to power x, we have used its answer, which we have already calculated in our earlier part of this problem, okay, plus 2, because in d over dx 2x e raised to power x, 2 is constant which can be written prior to d over dx, okay. Now in the next step, first half will remain exactly as it is because it has been found by previous working. Okay, plus 2. Here x into e raised to power x. One time we will keep yes students, one time we will differentiate x with respect to x and its answer will become 1, and ex will be kept as constant and it will remain as it is. And second time we will keep x as constant and differentiate e raised to power x with respect to x, and we know that derivative of exponential function is always in the first step exactly same exponential function as given, and then in the second step we differentiate substituted form of x. But here there is no substituted form of x. E raised to power x is in its purest form, so we will not have to take resort to the second step. Okay, so we get x square e raised to power x plus yes, dear students, actually x into ex, derivative of x into ex has become equal to x e raised to power ex plus ex. Now in this next step we are just going to simplify. Okay, x square ex, it is as it is, but 2x into ex plus 2x into ex, these two terms are similar. Okay, so these two will be added and it will, and these will give result 4 into x into e raised to power x plus 2 e raised to power x, because 2 which was constant will not only multiply with x ex but also will multiply with e raised to power x. Okay, so our next step becomes x square ex e raised to power x plus 4x e raised to power x plus 2 into e raised to power x. From here we get e raised to power x as common, and within the bracket we get x square plus 4x plus 2. Okay, this is our answer. Okay, problem number 32. Fx is equal to x square root or under root e raised to power x. We know that x square root or x under root can be alternatively written in the form of power half, power 1 by 2. So we have alternatively written it as x raised to power 1 by 2 into e raised to power x. So when fx is equal to this, then f dash x will be equal to d over dx into the same function as in previous step. Okay, so now once again product rule is going to be applied. One time we will differentiate one of these two functions and keep other function as constant, and second time we will differentiate other function and keep other function as constant. Okay, in an alternate manner. Okay, so dear students, first we have kept x raised to power 1 by 2 or x square root or x under root as constant, and we have differentiated e raised to power x. We know that derivative of exponential function is always exactly same exponential function in first step, and second step is derivative of substituted form of x, but here there is no substituted form of e raised to power x. E raised to power x is in its purest simplest form. Okay, so x raised to power 1 by 2 into ex plus second time we are keeping e raised to power x as constant, and we are going to differentiate x raised to power 1 by 2. How it will be differentiated? It will be differentiated using power rule. According to power rule, this power 1 by 2 will appear as a multiplying factor of x raised to power 1 by 2, and the power 1 by 2 will be reduced by one number. So when 1 is subtracted from half, then we get minus half, and we know that power minus half in the numerator is equal to or equivalent to power plus half in the denominator. So this x raised to power minus 1 by 2 will be shifted to denominator, and it will become x raised to power plus 1 by 2 in the denominator. Moreover, in the next step, we have once again in place of x raised to power 1 by 2, we have written it in the form of x square root or x under root. Okay. So our next step becomes x square root or x under root into e raised to power x plus e raised to power x in the numerator over 2 into x square root or x under root. Because its power was minus half, so minus half is converted into plus half by being shifted from numerator to denominator. Okay. So in the next step, we will take 2 into x under root or x square root as common, least common multiple LCM, and then this 2 into x square root or x under root will be multiplied with x and square root or under root into e raised to power x. So when 2 times x raised to power half is multiplied, power becomes full. Okay. X raised to half power into x raised to half power becomes equal to x raised to 1 power. That is to say, square of x under root or x square root is equal to x itself. So we get 2 into x into ex plus simply ex divided by 2 into x square root or x under root. Okay, this is the answer. This is the answer of f dash x. Now in the next step we will find its second derivative, that is to say f double dash x. So when f dash x is equal to this, then f double dash x will be equal to d over dx into f dash x. Okay. So this implies that f double dash x is equal to d over dx into f dash x. Now dear students, here we are going to apply quotient rule. According to quotient rule, function in the denominator is taken as square, while first we write the function in the denominator as it is without any change, and then we differentiate function in the given in the numerator, minus we write the function in the numerator as it is, and then we differentiate function given in the denominator. This is the formula of quotient rule. Okay. So dear students, first we have written 2 into x square and x and square root or under root as it is, and then we will differentiate 2x into e raised to power x plus ex, minus we will keep this term this part as constant, that is 2x into e raised to power x plus e raised to power x as constant, and we will differentiate 2 into x square under root. Okay. In the denominator, the function as given in original form has been taken in its square form. Okay. Now this 2 into x square root or x under root will remain as it is. Now x into ex, actually we have already found its derivative in our previous step, but it is not necessary. We can immediately once again take its derivative. Okay. 2 into x square root as it is. Now 2x e raised to power x. Okay. One time we have taken x constant and we are going to differentiate e raised to power x. In this way there will be no change in 2x into e raised to power x. But second time, when we will keep e raised to power x as constant and differentiate x with respect to x, then derivative of x with respect to x will become unity 1. Okay, so it will become similar. So here in place of x we will get 1, and so we will get 2 into e raised to power x plus e raised to power x will remain as it is, because we know that derivative of exponential function is always the whole exponential function itself in the first step, and in the second step we take derivative of the substituted form of x, but here there is no substituted form of x, and e raised to the power x is in its simplest form. Okay, minus 2x into ex plus e raised to power x will remain as it is, and we are going to differentiate 2 into x square root or x under root. Here 2 is common, 2 is a constant, so it will not affect, so it will be written as it is, but x square root or x under root which can also be written as x raised to power 1 by 2. So here while differentiating this we will have to apply power rule. According to power rule, this power, that is power half, will become as a multiplying factor of x square root or x under root, and its power, that is 1 by 2, will be reduced by one number. So when one full number is subtracted from half number, then we get minus half, and we know that power minus half in the numerator is equivalent to power plus half in the denominator. So that is why this thing has taken this form, that 2 is as it is, but derivative of x square root or x under root is equal to 1 by 2 x square root or x under root. In this way 2 will be cancelled with 2. Okay, moreover 2 into x square root or x under root whole square will become equal to 4x, because square of 2 is 4 and square of x under root is simply x, because x under root is equal to power 1 by 2, so power 1 by 2 into power 1 by 2 becomes equal to power full 1. This is not the answer. Next step will be taken in the next page. Okay, so we remember here this thing, and next step will be a continuation of this step. Okay, so next step, this 2 is cancelled with this, so 2 into, moreover, yes dear students, this is 2 e raised to power x, this is plus e raised to power x. Okay, this is 1 e raised to power x, this is 2 e raised to the power x, so these two will be added and give result 3 e raised to power x. Okay, so next simplification will be based on such things. Okay, 2 into x square root or root into 2x e raised to power x plus 3 e raised to power x minus 2x e raised to power x plus e raised to power x into 1 over x square root over 4x. Okay, 2 cancelled by 2. Yes, this is just a simplification, nothing else. We have taken derivative, required derivatives have been taken, and next step is just simplification. So after simplification, next term becomes this. Then here's what 2x, yes, what we have done, actually this power x raised to power 1 by 2, this will be shifted here, In other words, we have taken LCM as x square root or x under root, and this x square root or x under root will be multiplied to this first portion, which is 2 into x square root into 2x ex plus 3 e raised to power x. Okay, this first part, which is within parentheses together with 2 into x square root. Okay, this factor will be multiplied with x square root or x under root, and then we can write it as a whole upper portion over x square root multiplied by, denominator can be written as 4x divided by 1. So upper portion divided by x square root will be multiplied by 1 over 4x. Okay, this is just a simplification step. Okay, so that is why this 4x has been converted into 4x 3 by 2. That is to say x half power and x full power. These two powers are added, and we know that 1 plus half is equal to 3 by 2. That is 1.5. So that is why denominator has become 4 into x raised to power 3 by 2. And in the numerator, this x square root when multiplied with x square root, these two will combine and give result simply x, pure x, without a square root sign. Okay, so 2x into 2x e raised to power x plus 3 raised to power 3 e raised to power x minus 2x e raised to power x plus e raised to power x over 4x raised to power 3 by 2. Next, just simplification. 2 into 2 4, x into x square, and then e raised to power x plus 2 into 3 6 x as it is, and then e raised to power x as it is, minus 2x e raised to power x minus e raised to power x, because outside is minus, outside the parenthesis there is minus, so this minus will also apply to e raised to power x if written without this parenthesis. Okay, so next simplification gives 6x into e raised to power x, this is plus, and minus 2x into e raised to power x, this is minus. So from 6 2 will be subtracted, and we will get the result as 4 into x into e raised to power x. Okay, only this simplification exists, remaining all terms exist as it is. Okay, and next, in the next step, we will take e raised to power x from 3 terms occurring in the numerator, and hence our answer will become e raised to power x common, and then within parenthesis 4x square plus 4x minus 1 over 4x raised to power 3 by 2. This is second derivative. This is second derivative. Okay, so problem number 32 has been solved. First derivative as well as second derivative. Now we come towards problem number 35. 35, y is equal to tx square plus t cube x. This implies that dy by dx will be d over dx into the whole function. Now students, when we are going to differentiate tx square plus t square x with respect to x, then t will operate as a constant, and differentiation will only apply to x square and simply x. So our derivative with respect to x will become 2x into t or 2tx. Okay, plus d over dx d over dx 2tx 2tx yes yes dear student, okay, yes, there is a minor mistake. This d over dx, then within parenthesis the quantity is not written as actual figure. Actual given quantity is tx square plus t raised to power 3x, but here mistakenly tx square plus t square x has been written. So this is creating trouble. That is why this step is not corresponding to this. Otherwise this answer is given correct 2tx, because when t will be kept as constant, this first term will become 2x into t, or in other words 2tx, while plus t raised to power 3x, when it will be differentiated with respect to x, then in place of x we will get unity and t raised to power 3 will become as it is. Next, we differentiate y with respect to t. dy by dt is equal to d over dt into the whole function as given in origin. Dear students, here it is written correct, exactly, okay. In case of d over dx there was a minor mistake, but in case of d over dt there is no mistake, okay. Now we are going to differentiate with respect to t, so x factor will operate as a constant. So in place of t we will get unity, because dt over dt, differentiation of t with respect to t will be 1 or unity, so we will get x square plus, in the second term x will remain as a constant and we will differentiate t raised to the power 3, so it will become 3t square into x, okay, because x is being treated as constant, and it will remain as a multiplying factor with t cube, and t cube will be changed into 3t square, so our answer will be x square plus 3t square x, okay. So this problem number 35 has been solved from both angles. That is, we have calculated not only dy by dx but also dy by dt. Problem number 36, y is equal to t over x square plus x over t. We know that this can alternatively be written as t into x raised to power minus 2 plus x into t raised to power minus 1. What change? We have shifted x square from the denominator to numerator, that is why its power has become minus 2. Similarly, we have shifted t from denominator to numerator and hence its power has become minus 1 from plus 1, okay. So when y is equal to this, then dy by dx will be equal to d over dx into the whole function as given in original form, okay. Now while we are going to differentiate with respect to x, t will operate as a constant factor, okay. So d over dx tx raised to power minus 2 plus x into t raised to power minus 1 will become minus 2xt minus 2 dy by dx is equal to d over dx tx raised to power minus k. Yes, okay, no confusion, dear students. Because we are going to differentiate with respect to x, So power of x, that is minus 2, will become as a multiplying factor of tx minus 2, tx raised to power minus 2, and power minus 2 will be reduced by one number, that is this minus 2 will turn into minus 3. Okay, so that is why derivative of 2x raised to power minus 2 with respect to x becomes minus 2tx raised to power minus 3 plus derivative of x into t raised to power minus 1 with respect to x will become t raised to power minus 1, because in place of x we will get 1 unity, because derivative of x with respect to x is 1. So we have get our answer as minus 2tx raised to power minus 3 plus t raised to power minus 1. And in the next step we have once again written them in such a way that minus power has been converted into plus power by changing their position from numerator to denominator. Okay, so t raised to minus 1, which was written at second place, now it has been written at first place, because it does not make any difference. In place of t raised to power minus 1, we have written 1 over t minus x raised to power minus 3 will become x raised to power plus 3 in the denominator. That is to say, it has become minus 2t over x raised to the power 3. Okay, so here one part of the problem is solved, and now we are going to solve dy by dt. While finding dy by dt, we will have d over dt into the whole function as given in the previous part. Okay, d over dt tx raised to the power minus 2 plus xt raised to power minus 1. Okay, because here we are going to differentiate it with respect to t. So x factor will treat or operate as a constant factor. Okay, so in the first part, x raised to power minus 2 will remain as it is, and in place of t we will get 1 or unity, because derivative of t with respect to t is 1 or unity. Okay, that is why we have get x raised to the power minus 2, and derivative of second term with respect to t will become minus t raised to power minus 2 into x, because x is going to be treated as a constant factor, so it will remain as it is as a multiplying factor. Okay, so second term becomes minus x t raised to the power minus 2, and in the next step we are once again changing minus power into plus power by shifting their place from numerator to denominator. So in the next step our answer becomes 1 over x square minus x over t square. This is the solution of our problem number 36. This is the end of our video. This is the end of our 4 problems, which were originally 8 problems. So till next video, Allah Hafiz.